Let's do some more problems that use the fact that the derivative is the instantaneous rate of change. So I'm going to throw a cup of coffee up in the air. Don't know why I would do that, but this is what the problem says I do. And now its height above the ground as a function of time in seconds is given by this function h of t. It's 5 plus 9t minus 2t squared. And now we're going to measure that height in feet. Feet above the ground. So, here's our task. We have to find the height and velocity at time t equals 2 seconds. Pretty straightforward. So first of all, notice that to find the height, we already have the height function. We don't have to use the derivative or anything. So the height of the mug at t equals 2, that's just given by plugging in 2 into the height function. So that's pretty straightforward. I'm plugging in t equals 2 in my function h of t. I just plugged in 2 everywhere for t. And now we just need to do this arithmetic here. 9 times 2, that's 18. So when we add 5 to 18, we'll get 23. And then here we have 2 times 2 squared is 2 times 4. That's 8. So we have 23 minus 8, and that's 15 feet. So the height at time 2 is 15 feet. For the velocity, we're going to use the fact that the derivative of the height function, the instantaneous rate of change of height, is exactly the velocity of the mug at time t. And now, to compute this derivative, let's use these basic rules that we now have. So the function is 5 plus 9t minus 2t squared. So I'm going to write this in steps. Let's remember our d by dx notation. Here I'm going to use d by dt since we're taking the derivative with respect to the variable t. So you can think of subtracting 2t squared as adding the function minus 2t squared, if you like. So here I'm just writing out that the derivative is linear. You can take the derivative of each piece that you're adding up one by one to compute the derivative of the whole thing. All right, onward. 5 is a constant function. Its derivative is 0. The constant 9 comes out of the derivative. It doesn't affect it. And then we're just multiplying by what's left, the derivative of t. The derivative of t is 1. Similarly here, the minus 2 comes out as a constant. So you can think of that as adding minus 2 times the derivative of 2t. What's the derivative of, the derivative of t squared? I already said what it is, it's 2t. So here, t squared, the derivative of that piece, becomes this. And so the velocity function is 9 minus 4t. Very nice. Now, that's the velocity at some arbitrary time t. To find the velocity at 2 seconds, we just need to plug in 2 into the derivative function here. We just computed what that is. So I plug in t equals 2 into that function. I get 9 minus 4 times 2. That's 9 minus 8, and I get 1. So the velocity is 1 foot per second. Notice that that's a positive number, so it's actually still traveling upwards at this time. Why is that? If we look at the graph of h of t, the graph of h of t as a function of time, it'll look something like this. We start at some height. It turns out that that height is actually 5. And then as time progresses, the mug goes up, and at some point it turns around, and then it crashes down to the ground some point later in time. And now 2 is going to be somewhere around here on the graph. So here, if you think about the tangent line, if you think about the rate of change of h of t, that slope is what the derivative is measuring. Here, h prime at 2, that would be the slope of the tangent line of this function. That's a positive number. So it's still pointing upward. It's still moving up into the air. The coffee mug is still going upwards at time t equals 2.
Room service.
We're not done with the coffee mug yet. We're now going to ask the question, when does the coffee mug hit the ground? That's our next question. Well, remember that the height function is given by 5 plus 9t minus 2t squared. That's the function we had before. That's not the derivative, just the original height function. And here's what I'm going to do. I'm going to set that function equal to 0. Why am I going to do that? Because the idea here is that when h of t is equal to 0, the mug is at height 0, so it's on the ground. And now that we've set that height function equal to 0, we're just going to solve for t. That'll tell us when the mug is on the ground. Okay, look at this function. How do we figure out when it's equal to 0? You might be real clever and see how to factor that quadratic polynomial, but I'm not so sure. I can't really see how to do that. So what I'm going to do is I'm going to rewrite the equation that we have up there, but I'm going to do it in the opposite order, like this, with descending powers of t instead of ascending powers of t. And the reason for that is that I'm going to use the quadratic formula to figure out what the roots of this equation are. I'm going to solve for t in this equation using the quadratic formula. Remember, in the quadratic formula, a, b, and c are the constants in front of the second power of your variable, the first power of your variable, and the constant term. You can think of that as the 0th power of your variable, if you like. So then let's apply the quadratic formula. It says that the solutions in general are given by minus b plus or minus the square root of b squared minus 4ac, all divided by 2a. That's the quadratic formula. What does it say in this instant? In this instance, well, b is 9 here, so I'm just going to start plugging in values into our formula. B squared, that would be 9 squared, that's 81. And then we have minus 4ac. What was a? It was minus 2. Careful with the minus signs. And then what was c? It was 5. So that's the term under the square root. And then downstairs we have 2 times a. What was a? It was minus 2. So that big messy formula is going to give us the solution, the time where the mug hits the ground. Let's simplify. Underneath the square roots, we have 81 minus 4 times minus 2 times 5. Let's see here. 4 times minus 2, that's minus 8. And if we multiply by 5, we'll have minus 40. But there's 2 minus signs, so that's going to be 81 plus 40. 2 wrongs make a right. And downstairs, 2 times minus 2 is just minus 4. Very good. Let's see, what's 81 plus 40? That's 121. Do you recognize 121 as a square? That's one of those good ones to remember. 121 is 11 squared. So in fact, that square root is just 11. And now let's remember what the plus or minus notation means. It means there's actually 2 solutions here. There's minus 9 plus 11 over minus 4. And the other possibility is minus 9 minus 11 over minus 4. The point is that the plus or minus is just saying that, hey, both of those possibilities are giving us solutions. And now let's simplify here. Minus 9 plus 11 is 2. So 2 divided by minus 4 will be minus 1/2. And then here we have minus 20 on top divided by minus 4 is positive 5. So those are our solutions. The mug is on the ground when the time parameter, the t variable, is minus 1/2 or 5. And remember, we're measuring time in seconds here. Now, what's up with minus time? How do we make sense of that? Well, remember the graph of our function. We were actually starting at a height that was positive. And we want to know when it hits the ground over here. This is the trajectory of our mug as a function of time. So that t equals minus 1/2, that's just a sort of artifact of the model. It's not actually a real thing that's happening. T equals minus 1/2 is an artifact of the model. This is just something that we're getting that's happening before the mug is thrown. What's important is the positive t value. That's the time that the mug actually hits the ground, and that'll be this other solution. So the mug hits the ground at 5 seconds after I threw it.
Warm milk.
We're not done yet. Next, we're going to ask, what is the velocity of the mug when it hits the ground? So we already computed that the velocity, which is given by the derivative of the height function, is given by 9 minus 4t. We computed that earlier. So that's the velocity function. And then we just figured out that the mug hits the ground at t equals 5. So to answer this question, to figure out what the velocity is, we just need to plug in. And this is what's so cool about the derivative. You can get a formula for the derivative that works for all t, or for all x, for any input, because you have the derivative as a function. And then to find specific information, you just need to plug in. So if I plug in t equals 5 here, I get 9 minus 4 times 5, that's 9 minus 20, that's minus 11. Remember, our units are feet per second. So that's saying that the mug hits the ground at a speed of 11 feet per second. Why is it negative? That's just showing that it's moving in the downward direction. Negative velocity in this case, because of the way we set up the problem, that's just corresponding to the downwards direction, towards the ground.
The milk will get cool on you pretty soon.
We're not done with the coffee mug yet. I have one more question. When is the mug at the highest point of its trajectory? How high does the mug get at its highest point? So there's two different things we need to answer here. There's a when and there's a how high. And to help us answer it, let's look at our little sketch of the graph again. There's the trajectory of the mug. We figured out earlier that it crash lands down onto the ground at 5 seconds. And you might think that here, this is the highest point, right? This is called the apex of the parabola. Apex just means highest point. You might think that that point at the top of the parabola is going to be exactly between 0 and 5. So it happens at 2.5. But that's not quite true, because remember, this parabola is a little bit off center, right? This point is symmetric with this point, the negative t value, the negative 1/2 that we found before. It's not symmetric here with 0. So we need to be a little bit more clever. Here, check it out. If I think about the tangent line, or equivalently, the rate of change of height, which is to say the velocity at different points in time, that corresponds to the slopes of these different red lines, we can see that the special property that the apex has is that before the apex, the velocity is positive. I'm not saying that the height is positive. The height is always positive. But here the mug is moving upwards, so it has a positive velocity up until the apex. After the apex, the velocity is negative. After the mug has turned around and is going a different direction, it's moving downwards. It has negative velocity. It's moving in the opposite direction as the direction in which we're measuring height. And now the apex, that special point, if you think about the tangent line at the top there of the parabola, that tangent line's totally flat. So the apex, the highest point of the trajectory, occurs exactly when the velocity is equal to 0. And this should make sense from normal life, right? If I throw a coffee mug up in the air, there's that instantaneous moment when it holds still and then begins to fall. And that instantaneous moment at the apex is exactly having velocity 0. That's the mug turning around and starting to fall. But we have a formula for the velocity of the mug. We've computed the derivative of this function. We found that the derivative of the height function was 9 minus 4t. That's the velocity function. And so here's what we're going to do. We're just going to set that velocity equal to 0 and figure out the t value that makes the velocity 0. So now let's solve for t. Let's see, we have 9 minus 4t equals 0. So if I add 4t to both sides, if I move the 4t over to the right-hand side, it becomes positive 4t. And so dividing by 4, we see that t is equal to 9 over 4, which is 2 1/4, so that's 2.25 seconds. All right, so that answers the when. The highest point, the apex, it occurs at 2.25 seconds. That's this point right here. So this was at 5, and this apex is occurring at 2.25. It's not quite halfway between 0 and 5, but it's awful close. Now remember, there was a second question we were supposed to answer, which was, how high does the mug get at its highest point? Well, now that we know the when, we can answer the how high. To find the height at the apex, we're just going to plug in this t value that we just found into the original height function. Not into the derivative of the height function, but into the height function itself. So in other words, we're going to evaluate the height function at this t value. Now I'm going to use 9/4. I sort of prefer fractions to decimals, but if you like 2.25, you could do it that way. We have to remember what the height function is. It was 5 plus 9t minus 2t squared. So I'm going to evaluate that function at t equals 9 over 4. So it was 5 plus 9t minus 2t squared. So we need to evaluate at 9/4 squared. So that's the answer. The mug reaches a height of 15.125 feet at its height, maximum height.
I heard about you.